Alright, so in this video we're going to look at the characteristic of a parallel circuit, and we're mainly looking at the current. This time characteristic, it's a I here instead of a that I had mentioned in the first video. Alright, so we have a parallel circuit with R1 and R2, and this is the arrangement of a simple parallel circuit. Now we're looking at the current in a parallel circuit, relating to the characteristic of this parallel circuit. Now, the current that is flowing through the parallel circuit as it leaves from the source here, which is a battery, as it leaves from the source, comes into this one piece of wire, but as it reaches this junction here, some of the current is going to split, come up to this side, some is going to split and go down to this side. Now, this is a characteristic of a parallel circuit. So the current in the parallel circuit is divided among the resistors. So say for example you have 3 amperes of current coming from the source. As the 3 amperes reaches this junction, some of it is going to come up here. So let us say that I1 here is equal to 1 ampere. 1 ampere. I2 is equal to 2 ampere. So if you add I1 and I2, you should get back the total current, which is I3. So let us look at IT. So IT is the total. So as I said before, as the current travels to this junction, some of it is going to split and go to I1, some is R1, some is going to split and go down to R2. But as it split, the current now at I1 is now 1 ampere. The current at I2 is 2 ampere. So that if you add I1 and I2, you should get back the total current I3. Now, another way of explaining this that I normally use to my students is that we assume that the current flow is like water in a pipe. So as the water flow into this single piece of pipe, all of that water flow into the pipe. But as the water reaches this junction, some of it is going to split and come up this side because there's a part here available for the water to flow. Also, some is going to come down here because down here is another path where the water can flow. But as both part separates and then it recombines here, the total is now added back here and flow right back to the source. So we get 3 amperes coming back into this single wire coming to the source. So as the water flow into the single line, reaches the junction, some split come up here, some split go down here. So that if you add these two sets of water together, you should get back the same total that is from the source. So as both of them split and come back to the end junction here, both of them recombine. So if you add the total, if you add what you get here and here for the current, you should get back the same 3 amperes, which is the total flowing back down here. So this is a characteristic of a parallel circuit. The current in a parallel circuit divide among the resistors in the circuit. So we have 2 resistors here. If we had 3, the current would have divided among the 3 resistors. If we had 4, it would have divided among the 4 resistors. If we have 5, 6, 7 resistors, the current will also divide among those 7 resistors. So any amount of resistors you want to have in the circuit, whatever the total is, it would have divided among all of those resistors within the circuit. So again, another characteristic of a parallel circuit.